So what we show here, this is a maintenance-free battery, and we're showing 12.55 volts. Realistically, that's a little low, but we've started the bike a couple of times, which means we've kind of drained some of that surface voltage off. What we do not want to do is, get that on there a little better. Get that out of the way. What we don't want to do is consider that that means the battery's good, okay? So from there, what we do is we do a traditional method of a load tester. And with this load tester, we could take and we put these heavy-duty clamps on here. Once again, battery out of the machine. And this gives us our surface voltage reading. And then when I hit this button here, what that does is it cranks down an internal load on the battery to see if the battery doesn't fall less than 9 volts, okay? If it falls less than 9 volts, as you can see, it's gonna register bad. Maintenance-free batteries typically fall to about 10 volts. Conventional batteries fall to that 9 range, and then it just holds there. If it leaks down, the battery either needs charged or replaced, and you can see some of our other videos for that. But what we're gonna do is we're gonna go ahead and use the bike starter as a way to measure the load testing of this battery. So let's bring this meter closer here. Why don't you go ahead and just set it like that. You could see, obviously, we're hooked up. You could see what our voltage is. I'm going to go ahead and start the motorcycle. And what we're looking for on the load testing here, why don't you students tell me, is we want no less than what? 9 volts. So as we crank this over with the starter, if that gets less than 9 volts, we have a battery issue of just needing charged or replaced. So let's check out and see what happens. What did it get to? The lowest. It got a lowest of about 10 volts. I think I saw 10.32 volts. What we're going to do now is we're going to check the charging system. Kind of a noisy RC51, isn't it? Pretty cool bike. What we're going to do is, and do you notice how just for running for a couple of seconds, would the battery jump up to? And it actually, I saw 13 on there. In a couple of seconds of running, this thing jumped up to 13 volts from that 12.5. That's just surface voltage in there that the charging system is just pumped in there right now. This bike, can you back up on the camera and show that there's no headlights, there's no tail lights? We're in the process of building this race bike, and we don't have any of that street equipment hooked up on this, so we don't have a lot of draw on the electrical system. So what you noticed at idle is that this was jumping up into that 14.3 or 4 range or whatnot. We have to, per the service manual, run this to a certain RPM. It's going to get kind of loud on the video. And check what's called our break-even voltage to make sure that the system isn't also overcharging or not working through that range. A lot of motorcycles out there, especially your older bikes, at idle do not produce charging voltage. And so if you just hook up a voltmeter like this to the battery and try to check for battery charging and you don't rev it to the specified break-even, if I just go and go, oh, I only have battery voltage, I'm going to say there's something wrong with the system and I'm checking a bunch of stuff that I don't need to. So, Tyler, go ahead and hold that for us again. We'll fire up the bike. Notice how it's getting hard to start? We're draining that down. Okay. What we're going to do is, we know that our bike's working fine, but we're going to go ahead and demonstrate the test that we would do to test the components individually. So we're going to start with a parasitic draw test. Let's go ahead and switch meters. Now, per the manual, it says to disconnect the negative host. Okay, let's show your meter right here. So what you're going to see here is when you do amp testing, we need to complete the system in what we call a series test. You have to watch some of our other videos for more information on that. But in a series test, we need to go through the meter. So what we want to do to not have a negative sign show up on this is we're going to go ahead and hook our positive up to our cable, because the battery flow right now is going from the battery through the motorcycle electronics through the negative cable. Now we're going to go through the meter, out of the meter, and then we're going to go ultimately to ground with the ground cable here. Okay. What you're going to see right here is the service manual also tells us always start on the largest range. And on this particular bike, per the manual, can I see that manual again? Let me just show the spec on that. It says that the maximum current leakage that we want to see is 1/10 of a milliamp here. Okay? That's the maximum, 1/10 of a milliamp. Okay? Now, when I start with this largest range, you're going to see that I got this kind of dancing back here. Every once in a while, you see that one that's dancing over there? Well, that really is a problem for us. Now we're going to switch to the smaller range. We're going to go ahead, and we're going to be able to see now that one's showing itself. So that's 1 milliamp. Okay, the key's in the off position, but it says the most we're supposed to have, and this is why this one's confusing, is we're actually only supposed to have 1/10. We should be on the other side of that decimal, so we have a pretty excessive draw. Per the service manual, they tell us right away the next step, as we follow through here, it says if this problem is present, as we use our troubleshooting chart, it says, where did you find that? Disconnect the regulator and rectifier. So this says incorrect. We go here and follow these steps. So that's how a great way to use troubleshooting charts. So let's just go ahead and do that. That component right here, you just see here when I disconnect this, did our problem go away? Most of it. We still have the clock hooked up and some other things, but we got down into a much smaller number here. Not completely, but if we were to take, now we still see that we have a draw there. So what we could do is we can go ahead and start disconnecting fuses one at a time. So here, if we start looking at our fuses here, here's an odometer one. As I pull that one, we went to 0. Now I could have, show the camera up here, I could have disconnected the actual connector here, and you could go around, you could keep just disconnecting things until your problem goes away, and what's really nice about that is you know where it exists. This number is really super small here, but what we find to be interesting is we've already been playing around and diagnosing this bike, and go ahead and go back here. Let's move our meter back to here. Okay, this is the regulator rectifier on this RC51, and one thing I knew and noticed about this motorcycle is this is not stock. Here's an actual stock one. You see it's much larger in size. My connectors are exactly the same, but this is an OEM one, okay? Now I want to show you something that's pretty interesting here. So we're going to go ahead, and once again, we have this disconnected here. I'm going to go ahead and fully disconnect the stator side of it too. Okay, we have no change in anything. But now what I'm going to do is I'm going to hook up a stock OEM one. Yeah, you can grab that, Brent. Okay, now remember we had that one before, right? So now as we have this, we're basically holding this onto the chassis here. I'll go ahead and even just hook it up fully. Okay. We've got this, resting on here. It's not the same as being bolted on. So this one's disconnected, and you can see what we have happening here. So watch this. Just to prove a point, we do a lot of things around here called AVA testing. I'm going to go ahead and, okay, I'm going to switch back to this aftermarket one, the one where we think we have the problem, and look at our problems back. Okay, so we know something's going on. Problem present with this one, but the one thing we haven't done is actually ran the bike to see if the charging system still works. So go back to DC volts. So what you could see through our testing, we'll come back around on this side, is that for whatever reason, this aftermarket And we weren't looking for a problem. We didn't like have a complaint like, hey, the battery's going dead or anything else. This would draw the battery dead though, super fast. When it's only supposed to be 1/10 of a milliamp and it was drawing 1 milliamp, that would definitely drain the battery a lot faster. Now, the only way we'd really know how long is to leave it on there, measure it each day, and then see how long it would take before the bike wouldn't start. But great example of how to identify that, just disconnecting things, find the source, and then fortunately for us, we had a different one to exchange out. The service manual does just say to replace the part. There's no test for this when that current draws like that. It's just replace the part. It's a problem, and that's exactly what we did. All right, we're gonna move to another part of the video here, and we're gonna test the coil, the stator coil that's in here, and that's what comes up to this connector. So we're gonna go ahead and set it up for ohms. Can you grab that? Let's see if you guys remember this from your because you guys were using your training boards, weren't you? So what I'm going to do is just make it easier here. And we're going to, we have a coil in there with 3 windings. And what we want to do is we want to test between all those windings. Okay, so hook up 2 leads. Hold this, please. And it is best to use alligator clips and leave it alone, okay? Zeroed our leads to take out any potential resistance in the leads themselves. So now we're going to go ahead and hook across the stator. It's fine, I'm not confusing. Alright, just going to go one leg to another. 0.5, that one's good. Switch it. Those fuses really throw us off on those poor leads, aren't they? 0.5, now switch the middle one over. So the continuity between all those is good. And even if we went to 0.6, we had 0.1 of resistance in there. We would subtract that from those. So we're good. We're within our specs. So now we just take one side of this, and we're going to go to the negative battery cable here since we're still hooked up, and we should have nothing. Okay? We know they all have continuity to each other, so we don't need to switch in between each of those. So this stator's testing good, which we would expect it to. What we're going to do next, and this is what I don't think you guys have done yet, is we're going to do an AC output test. So that means we need to run the motorcycle. We're going to just simply switch our meter. We don't have to switch leads. We're going to go to AC volts. We're going to go ahead and start the motorcycle. Let's see, will you do that? Yeah, and can I see the manual? I'm going to see what the spec is, if they give us an AC output spec. All right, go ahead and fire up the motorcycle. What you're able to see here, hold that. What you're able to see, got to be hooked up across 2 coils. We're making 27 AC volts across those 2. If I go here, 27, and I go here, I have 27. Go ahead and rev it up to 5,000. Okay, what we saw is at idle we had what, 25, 26 volts AC across all 3 legs. What we want is we want them to be equal. I mean, if we had 20 across all 3 of them, remember in that Suzuki video, that mechanic to mechanic video, they talked about, you know, even if the spec was a little low or a little high, as long as they were all the same, the stator's probably good. It's just how many times it's wound around there. And then you notice as we revved it, did you see how high that AC voltage got? That is exactly why. So at idle, we have 26 volts AC. We're going to rectify it, change it to DC volts, and we don't want any more than 15.5 going into the battery. You can see how important it is to rev the engine up, because at 86 volts AC, does this regulator rectifier have a lot bigger job to do? Yeah. Okay, guys. That's some multiple ways that you could test the charging system on your motorcycle. It's very similar from one model to another.